All right, so in the middle equation there, we have two logarithms being added together on the left side. So first thing I probably should do is condense those down, right? I'm going to use a product property here. Make this log base A of x times x minus 2 is equal to log base A of x plus 4. Now that I have a single logarithm equal to a single logarithm and they have the same base, I can use property 7 up here, and I can effectively take the logs out of play and just set the arguments equal to each other. So how about I distribute this? I'm going to make this x squared minus 2x equals x plus 4. And I'm going to get everything to one side. I'm going to factor x minus 4, x plus 1. X would equal 4 or negative 1. All right, now just like the equation to the left here, I'm going to have to throw out this negative value. Not just because it's itself negative. It's all about if I make any of these arguments of the original logarithm in the original equation, if I make any of those negative by plugging negative 1 in, then it has to be ruled out. Why? Because you cannot take the log of a negative value. That is undefined, right? So the only solution here would be 4. All right, now the third equation, what's different about that one from the previous two?
The solution does not have the same log base.
I'm sorry, say that again?
There's no log base 2 on the 3.
Yeah. The right side of the equation, that's not a logarithm. It's simply the integer value of 3, right? So that's going to change my approach here a little bit. Now I'm still going to start off the same way as I did on the last equation. I'm going to condense the left side here. So I'm going to make that log base 2 of x plus 1 times x plus 7. That's going to equal 3. And now, since the right side does not have a logarithm, I'm going to convert to exponential form. So I'm going to say 2 to the third power equals x plus 1 times x plus 7. I'm going to actually multiply that out. I'll make that x squared plus 8x plus 7. Not that you have to, but I personally like everything being on the left side. So this is going to ultimately give me x squared plus 8x minus 1 equals 0. You're going to try to factor that at this point. It is not going to factor, though. So how can I solve a quadratic equation when factoring fails me? You could do quadratic formula, or what's the other method? Not quite. It's the one that doesn't get enough love, in my opinion. Completing the square. Okay, I don't really care which method you do, although I would argue in this particular situation with a leading coefficient of 1 and an even b value, that is perfect for completing the square. Okay, so I would make this x squared plus 8x plus a blank, add the 1 over, add a blank to that as well, right? Because if I'm going to add something on the left side to complete the square, I need to add it to the right to maintain equality. What number would complete the square here? 16. How'd you get that?
You take half of the exponent of x, which was 8, and then you square it.
Yeah, half of the coefficient here, 8, which is 4, square that to 16. Add that to this side as well. All right, so this will now factor to x plus 4 squared equals 17. I'm going to take the square root of both sides. X plus 4 will equal plus or minus the square root of 17, or x equals negative 4 plus or minus the square root of 17. Now, we're going to approximate here to see if we need to throw either of these solutions out. So, negative 4 plus the square root of 17 is 0.123. Negative 4 minus the square root of 17 is negative 8.123 approximately. Okay, now, would either of those values, when I plug them in to the original equation, would they make either of the logarithms undefined? Yes, which value would? Yeah, I got to throw that out. If I were to have added that in to 1 or to 7, that would result in a log being evaluated with a negative. Once again, undefined. Okay. The 0.123, that can stay though.
Is there ever a scenario where there'd be no solution?
I mean, I suppose, yeah, but probably won't run into that. All right, example 4. This is just a different spin on using our properties here. It says express y as a function of x. Basically, come up with an equation where y is written in terms of x. Okay? So notice the right side of this equation, you've got 3 logs being added together. Well, I can condense those down into a single logarithm. I can make this the natural log of x times x plus 1 added with the natural log of c. How about I actually multiply that out? And then those 2 logs can be condensed again using another product property. And I'll make this the natural log of c times x squared plus x. And now that I have a single logarithm equal to a single logarithm where they're both the same base, in this case a base of e, I can just set the arguments equal to each other. Y would equal, how about we distribute here, c times x squared plus cx. Now is y written as a function of x? Absolutely. And just a different spin on using our properties here to condense. All right, a couple more examples. Evaluate. Find the value of each of these expressions. 4 to the 3rd power added with log base 4 of 5. So all of this is your exponent on the 4 there. All right. Well, I could break this up, couldn't I? 4 cubed times 4 to the power log base 4 of 5. Right? I think if I were to work backwards from this, to multiply those 2 together, since they have the same base of 4, I would add the exponents, right? Okay, what is 4 to the 3rd power? And what is 4 to the power log base 4 of 5? 5. Okay, 64 times 5, 320. Okay, so similar process on the next one. How could I rewrite e to the power natural log 2 minus 4? Using maybe some properties of exponents. Yeah.
E to the natural log 2 over e to the 4.
Like that?
Yeah.
Perfect. Okay, so I got to use quotient here because there's subtraction within the exponent, right? What is e to the power natural log 2. Just 2. Now e to the 4th, we could approximate that, but we're just going to leave it in an exact form. It's pretty common to leave things in terms of e, like this. Questions on either of those? All right, final example. Okay, we have a logarithmic inequality here to solve. Now, there's a couple things we got to watch out for on this one. So the first one is what's written in red there. Be sure to consider a domain restriction. So when you solve an inequality, typically your inequality, your solution is an inequality that represents an infinite number of values, right? Well, we have to be mindful, maybe some of those values end up making this negative. If so, we'd have to throw them out. Just like when we are solving our equations, sometimes we get an extraneous solution that has to be thrown out, right? So it's no different here with an inequality, okay? Now, I'm going to condense the left side here using a quotient property. That's going to be common log of 5 minus x over 7 is less than 0. Now, what is the base of this logarithm? 10. Okay, now at this point, probably a good idea to go to exponential form. I'll make this 10 to the 0 power, and then you're going to be tempted to say less than 5 minus x over 7. Okay, but how do I really know that that's as is when I put 10 to the 0 power first on the left side? Am I supposed to keep that inequality as a less than, or should it be flipped? Okay, well, think about your argument here is 5 minus x over 7. Let's try to simplify that for a moment. Let's treat this like log base 10 of just a is less than 0. And let's think about some different values that would be useful for us to plug in for a. So starting with, what's log base 10 of 1? That's exactly 0, right? Okay, now, what's log base 10 of 10? 1. Log base 10 of 100? 2. Okay, so what I want you to notice is that as I continue to increase this value for the argument, notice the result keeps increasing, right? Is that what I want for this problem? If you go back to the inequality, I want it to actually be getting smaller than 0, not bigger than 0, right? Okay, so that means I need this argument of 5 minus x over 7. I need it to keep getting smaller, all right? So I need this to flip. And I need to make this now 10 to the 0 power is greater than 5 minus x over 7, which isn't that the same as saying 5 minus x over 7 is less than 10 to the 0? I need to get smaller. All right, now 10 to the 0 power is 1. Multiply both sides by 7. Subtract 5. Divide by a negative. That'll require you to flip the symbol back. So I end up with negative 2 is less than x. That's the same, of course, as saying x is greater than negative 2, right? Now, at this point, you're going to be tempted to stop and say that's your solution. There's an infinite number of values there, right? Some of those could make the original logarithms of the inequality undefined. So I'm going to go here. I'm going to say, well, the one logarithm had an argument of 5 minus x. I know that has to be greater than 0, right? So This is a domain restriction that I'm getting here. Has to be less than 5, right? So now I'm going to graph that with the x is greater than negative 2, and I'm going to look for the overlap of those. Greater than negative 2, less than 5. Where are they in common? Between negative 2 and 5. So that would be my final solution. Negative 2 to 5.